Chapter 1.8.9 Good Practices for Kubernetes Secrets. In Kubernetes, secrets are objects used to store sensitive information like passwords, OAuth tokens, and SSH keys. They help control access to sensitive information and reduce the risk of exposure. Secret values are stored as base 64 strings and can be encrypted at rest. Pods can reference secrets in various ways, such as through volume mounts or environment variables. Following best practices improves security for both cluster administrators and application developers, managing secrets and config maps in Kubernetes. Cluster administrators. The text provides good practices for cluster administrators to improve the security of confidential information within a cluster. It first recommends configuring encryption at rest for secret objects stored in etcd to protect the data. The next suggestion is to configure least privilege access to secrets using role-based access control, RBAC guidelines. This includes restricting access for components and humans and using third-party authorization mechanisms for more complex access control. The text also warns about the dangers of granting list access to secrets, as it could allow users to fetch the contents of the secrets. It recommends using short-lived secrets and implementing audit rules to detect unauthorized access. Additionally, service accounts can be annotated to enforce specific rules on how secrets are used in pods. Improving etcd management policies, such as wiping or shredding data once it is no longer in use, and configuring encrypted communication between etcd instances are also suggested for enhanced security. Additionally, cluster administrators can use third-party secret store providers to store confidential data outside the cluster, with the Kubernetes Secrets Store CSI driver allowing pods to access this external information securely. Overall, these practices aim to protect sensitive information within the cluster and reduce the risk of unauthorized access or exposure of secrets. By implementing these recommendations, cluster administrators can enhance the security posture of their environment. Developers. The text provides developers with good practices for enhancing the security of confidential data in Kubernetes resources. It suggests restricting secret access to specific containers within a pod, protecting secret data after it is read, and avoiding sharing secret manifests encoded in base 64. Developers are advised against logging or transmitting secret data and to be cautious about using base 64 encoding as it does not provide encryption. Overall, these practices can help developers maintain the security of confidential data in Kubernetes deployments.